Hi, I'm Kristen Haynes. I'm the Assistant Director out at Rice Creek Field Station, and I'm going to start teaching a couple seminar-style classes for the bio department starting in summer. So I'm trying to brush up on the best practices because it's been a couple years for me.
Okay, so I wanted to just give a general presentation on retrieval practice, space practice, and interleave practice, and then talk about some practical examples and just review some of the research on that. But let's get started. And the recording has started. Okay, so retrieval practice has been around for quite a while. It was first mentioned, I think, by Edwina Abbott back in 1909, except it was called the testing effect then. But it's been found in pretty much every study that's ever been done about how we learn, that the more students are tested on a concept, the longer they tend to remember it and the deeper they tend to understand it. And retrieval practice doesn't involve testing. In fact, I think the fact that it was called the testing effect discouraged people from emphasizing it too much, because tests are not something that students tend to think is being very positive. What really matters is retrieval, and the more students practice retrieving information, the better and the longer they're able to remember things. So it's also been called test-enhanced learning. But in general, it's not just tests that do this. It's basically what the research shows pretty much is that what students tend to do is they tend to practice storing information. They will keep rereading something over and over again. They'll highlight it, they'll study the highlights and so forth. But beyond the second reading something over and over again results in virtually no improvement in learning, even though it feels like there is. Because if someone reads the same text chapter, let's say 3 or 4 times, they'll recognize all the words, they'll recognize the layout. Everything they see will look and sound familiar, but there's only a slight gain from a second reading and virtually no gain beyond that. But if you practice trying to retrieve information, recall information, you're going to be able to remember it much more effectively, but it won't feel that way, which is one of the issues that we face. Here's an example of a study that was done it was in one of the research studies that was done as a basis of the book Make It Stick from that lab in Washington. I think it was, I think I've got the citation. There we go. It was Roediger and Karpicki, basically. This was done back in 2006. And what they showed is that if a student just studies something, reads it twice, if they're tested 5 minutes later, they do much better than if they studied something and then were tested on it once. So the immediate effect of reading something over and over again is that you can remember it better than if you read something and then were tested on it. But if you look at 2 days later, the rate at which you've forgotten information falls really rapidly if you just read something twice. But if you read something and were tested on it, the decline is significantly smaller. And a week later, the difference between the two becomes even more dramatic. That, you know, we tend to forget things. It's just a question of how we can slow down the rate of forgetting. And one way we can slow down the rate of forgetting materials is by simply having students practice retrieving. And the same is true for us, that the more we have to retrieve information, the more likely it is that we'll be better at being able to retrieve the information in the future. And there's lots and lots of studies. This one just had a pretty nice graph to illustrate it. And I somehow jumped out of that. Let me move back here. And there we go. And here's another test where this is one that was done. Again, I think Roediger was part. Yeah. Here's another part of that same paper, actually, where they had people read something multiple times, where the black bar is when they read something 4 times. The next is they read it 3 times and then were tested. And the third bar, the latest color one, is where they read something once and then were tested on it 3 times. And again, immediately rereading something over and over again lets you remember most of that information. But when you're tested a week later, you've forgotten virtually everything if you just read something 4 times. But if you read it and were tested on it read it 3 times and were tested, you remember more. Or if you just read it once, but were tested on it 3 times, you remember still more. So again, there have been countless studies on this, and they all find the same thing. But here's an interesting thing. This was another study done by by Kropicki and Blunt. And what they did is they had 2 types of questions: verbatim recall questions, inference questions, but they also asked students to predict how well the different types of study patterns were. Study just meant they read something once and then they were tested on it. They repeated study meant they read something twice. Concept mapping meant that they designed concept maps after a single reading. Retrieval practice is that they read something and then they were quizzed on it later. And I think this was a week later, it may have been more. And what happens is both with verbatim recall of what someone read, retrieval practice does better, or in terms of making inference, some degree of transfer, where you're trying to take concepts and apply them in a new circumstance, retrieval practice did better. But when students were asked how useful they thought each approach was, the most useful approach was repeated rereading according to their perceptions. Next was reading, and then concept mapping were about tied, and retrieval practice was rated lowest. And again, this is found over and over again, that students do not believe retrieval practice is very useful, yet it seems to be the most effective way to encourage long-term recall, as well as the ability to transfer information. And there's a few terms we use for this. One is fluency illusion, that when you read something over and over again, it looks familiar. You become fluent in it. It's all recognizable. Even if you don't fully understand the concepts, it looks familiar and you feel comfortable with it. And one of the problems is that when we use high stakes exams, the 3 midterm exam or 3 exams and a final, or 2 exams and a final, students know that in the short term, cramming works. And, if they just study things and read them over and over again before the test, they'll often be able to do really well on that test, but they'll forget nearly everything within a few weeks. So, what the research suggests is that low stakes or if you're going to use tests, low stakes or no stakes tests can be more helpful. No stakes tests requires a little bit more, perhaps, intrinsic motivation, which students don't always have, particularly freshmen. So, some form of low stakes testing can be really useful. And one approach that's used often in the STEM disciplines is some form of mastery quizzing, where students are able to keep trying something over and over again until they've achieved mastery. And one way of implementing that in Blackboard is just have questions that students can take any number of times, as long as you have a variety of questions. Could be a question bank, or you could, in some cases, use algorithmic questions. Just let students do it until they they've achieved some degree of mastery. And you can easily set that up where there's a limited number of attempts, maybe 2 or 3 or 4, or perhaps an infinite number of attempts, and you can only keep the highest grade, for example, or do some sort of weighted average of the highest. Well, there's many ways of doing it, but basically, letting students try something, make mistakes, and then learn from those mistakes can be really helpful. And that's built into a lot of adaptive learning and personalized learning systems that are automated to some extent. As I mentioned, it's not just retrieval activities. What might be? Actually, I was hoping we'd get more people here, but I was going to jump to a Jamboard, and I don't think with just the 3 of us here, I don't know if we really need to do it. What might be some other activities that would involve retrieval practice other than tests?
Well, what I do is, because terminology is like major, I'm sure it's important in all of our fields, but especially working with tools, I start with a glossary, and then I have them and a list of glossary terms and items. And after speaking about it for the first 2 weeks, I send the students on like a scavenger hunt. They have to apply what they're learning to the physical item. So I don't do a lot of sitting down at the desk learning sort of teaching at this point. When I'm teaching lighting, that's different because that's volts and amps and all sorts of math. But when I'm in the costume shop, they have to know the terms and the equipment and the items they're working with, because it's so hands-on practical application. So I start on little steps for them to remember.
And they have to use those terms in order to be able to accomplish those steps.
Yeah.
I would say polling, I guess, would be
Mhm.
the retrieval practice.
Where you could have students read something and just quiz them on it. Could be basic concepts or could be applications and so forth. Would be a good application. Any others that you can think of? I've got a few here too. Well, you could, at the start of class, and this is something a number of people do, is just at the beginning of a class, ask students what they did last time, and or what they've just done. It could be even in the middle of class. It's sometimes called a brain dump, where students are just asked to summarize the class to each other, where they work in small groups or in pairs, and they just write down everything they remembered, either from the last class or from the last 15 minutes of class, and then explain it and fill it out jointly, or just ask them to begin each class by saying, well, what did we do last time? And then you could even ask them to project what the next step would be. What are we going to go over next? Although if they keep track of the syllabus, or you told them that, that may not be too much retrieval practice, but that could be a simple way. And well, the brain dump activity, have students write down everything they remember and then fill in the gaps by sharing that. So if each student write down a paragraph or two, and then they could compare the notes, fill in the gaps, and then you could ask people to report back. I know Michelle Miller has done this quite a bit, and some other people who do a lot of retrieval practice have done that. And a nice thing about doing this at the start of class is it also activates prior knowledge, that presumably what you're doing in today's class is somehow related to what you were doing before, and just asking them to think back on what they just did helps bring that fresh, to make it easier for them to make connections to prior learning, which is also really helpful in learning. And again, you could also use this to predict or pretest what the next concepts are, where even if the concepts that you're doing next are not directly obvious from what you've been doing, asking students to predict what's the next logical thing to discuss, or to give them an overview of what you're going to be doing, and ask them to make some prediction about what it's likely we'll find when we get to this stage. So where students haven't discovered an answer, or they haven't yet been exposed to material that would let them answer a question, asking the question and having them think about what might happen in that case, or asking them, describing an experiment and asking them to predict the outcome, is a really good way of provoking curiosity, as well as activating prior knowledge and getting them thinking about everything they know about that to try to make a prediction, so that it's going to be easier for them to integrate that. So that type of thing is also really helpful, that sort of predictive or pretesting activity. And it does lead to deeper learning. It does lead to more long-term recall. There's been quite a few studies of that. Clickers are polling, as Kristen said. Kahoot is another thing that students often like, or some other quizzing thing where there's a little bit more of a game-like activity. You could even have students create their own Kahoot games. I know a number of people have done that, where students will create their own quizzes and then play them publicly in class for other students to respond to, or they could do that outside. Another activity for retrieval activities in a wide variety of disciplines is you could have students create reflective blogs or journals. The difference is a blog is generally more public, while a journal is shared only with the instructor. But having students engage in reflection on what they've learned and how they've learned it and what they've learned that's new is a good way, again, of having students retrieve their learning, where you ask them to reflect back on what they've done this past week and so forth. And that also tends to be somewhat helpful in increasing learning. Now, this is a really quick thing that people have used, and it's called an exit ticket or a muddiest point or a 1-minute quiz, which is generally given at the end of a class. We just ask students, let's say if we do the typical 1-minute quiz, you ask students, what did you learn today that you didn't know before? What do you still have questions about? Or what do you find confusing? You can pick questions like that. And then the act of reflecting on that, in some studies at least, have led to increased learning. There was one experiment done in economics where 2 classes of roughly the same size with very identical, well, with essentially identical student composition. One class used a 1-minute quiz at the end, one didn't. And there was significant learning gains in the group that used a 1-minute quiz compared to the other. Now, the samples were, I think, 50 and 50. So it was, it wasn't a very large sample. And in some other studies, that hasn't been found to have a significant effect, but there's at least some evidence in a few studies that can help as just a really simple form of retrieval practice, which could be done with students turning in a piece of paper, or it could be done by having students respond to a Google form where you put up a QR code and students enter a response right while they're in class from their mobile devices, smartphones, whatever. Or you could send it to them as a URL and ask them to do it later after class is over. And even though the evidence is a bit mixed, with no one has found it having no effect, but some studies have found no significant effect. Others have found a significant positive effect, and that seems to vary a bit by discipline. It does provide you with some feedback on what students are having problems with, which you can then use to respond to them in the next class. So that can be another way of using a simple form and a really quick way of getting some retrieval practice going. In general, though, not all classes will build this in. So we could encourage students, for example, to engage in retrieval practice on their own if it's not built into the structure of the course. They could do, for example, use flashcard apps with random shuffling so that they're not looking at things in the same order all the time. That could be helpful. We could also encourage students to work in study groups where they work either with a partner or with a small group of students, and they quiz each other. And that's another good way of implementing retrieval practice. And it also provides a bit of a commitment device, because if students are going to work with each other outside of class, they're much more likely to actually follow through, where if they say, we're going to meet every week from 5 to 6 in the library or in at the fireplace lounge or somewhere, they're much more likely to actually follow through than if they commit to spending more time studying on their own. You can embed online quizzing tools for self-tests in Blackboard. Many textbook publishers provide that, and so on. Now, in terms of feedback, retrieval practice, it's important that students not only retrieve information, but they get some feedback. And here, the results are kind of all over the place. Timely feedback is important. Very long delayed feedback is not very useful, but there is research that finds that some delay in feedback actually is more effective than immediate feedback. So that if students are getting immediate feedback when they get something wrong, that does not seem to have as much of a positive effect on long-term recall as if the feedback is delayed. Most of the studies I've seen that found this generally have delays of between, 24 hours and maybe a week. So it's not clear how long a delay. If you get it back months later, it probably isn't going to be very helpful, but you want the feedback to be timely. But some delay actually does seem to increase learning. And the reason why it's not entirely clear why immediate feedback may not be as helpful, it may be just simply because when you have more of a delay, you're also building in spacing and interleave practice, which we'll talk about in just a few minutes. But if you're going to do retrieval practice, there is that whole issue of fluency illusion where people get familiar with things they've seen many times. And when they're faced with retrieval practice, students tend not to like it very much because when they try to retrieve things and remember things, it's really easy to make mistakes and get things wrong. And that's not as pleasant as just simply reading something over and over again. So that's an issue we have to help students to get past. And the more we can motivate that, the better off we are. And in general, that retrieval practice on lower level concepts results in what's called automaticity, that students build in this automatic ability to recall information so they don't have to cognitively process the basic thing. You know, as Judy talked about with knowing the basic terms in the glossary, that once they become, the more they work with those terms, they won't have to consciously think about what terms apply. They're able to immediately recognize what concepts applies. And that's important in terms of building higher levels of cognition. So retrieval practice is important in order to be able to reach higher levels in Bloom's taxonomy, up to a point that too much retrieval practice actually can result in people locking in certain ideas, and it can actually limit transferability. So that if you practice something over and over again, you get to a point where you think of a problem only in one way, and you may lose the ability to look at things from a fresh perspective. And the research on this is pretty mixed, but you know, for example, if the only tool you have is a hammer, you know, that argument that if the only tool, how does that go? If the only tool you have, no. Now I completely forgot that sort of example, but the main point is that if you're only used to looking at things from one particular approach, it may be hard for people to see the same problem from a fresh approach if they over drill and over practice on a specific type of application. So retrieval practice is good, but there may be a point where it may tend to lock in a view that makes it harder for students to approach problems from a different perspective. I don't think that's a problem that we tend to run into, though, in most of our classes. Okay, and here's a set of resources with some of the research on that I'll put in the chat. And what I should have done, and I didn't, is combine the two presentations. I just kind of put them all together. So yeah, and there is that question that Steve mentioned in the chat about how long the delay should be. And the research on that is pretty mixed, you know, anywhere from 24 hours up to maybe a week or so is what seems to be helpful compared to immediate. But even just making it a few minutes later can be helpful, or it seems in some of the studies. And here's a whole host of studies on this that can be useful. And in particular, one site which is superb in terms of retrieval practice, as well as some of the other things we're going to talk about in a minute, is retrievalpractice.org. They have dozens and dozens of examples of good ways of building in retrieval practice into your class. So you don't have to keep doing things the same way. You know, you can bring in different approaches and different ways of doing it just to mix things up a little bit, which can be helpful. And certainly there's a lot of books out there. Powerful Teaching is written by one of the developers of retrieval practice. It's aimed at a high school audience, but it applies to college pretty well. Make It Stick is a classic work that is worth reading if you haven't done it yet. It's written by two cognitive psychologists and a novelist who put things together in a much more perhaps compelling narrative than if it was just done by, you know, the researchers there. And actually Peter Brown is a novelist, and he gave a talk on this a few years ago when we did a reading group on this. Small Teaching involved ways of building these sessions, these tools into short activities you can introduce in your classes. Michelle Miller book, Minds Online, involves all of these concepts and focuses a lot on ways of doing retrieval practice. And Michelle had a talk on that, you know, on our podcast. The Learning Scientists also have a lot of good research sources, which are really good to share with students on retrieval practice and ways in which students can benefit from this. Okay, so any thoughts or comments before we jump into spaced and interleaved practice?
Hi, John.
Yes.
You had touched base on this briefly, was the application of retrieval to different situations. I think one of my biggest problems, and I talk to colleagues about, is we will teach a solution and how to problem solve for a situation. They practice it, something comes up, they like stop dead and like, how do I solve this problem? When they've already pretty much used the technique
That they're
to,
familiar with. Yeah.
right. And I'm finding my students are having problems applying solutions that they already know to different
Different
configurations.
situations. Yeah.
Yeah,
Transferability, basically, that taking the concept you've learned in one area and applying them in an equivalent set of circumstances that are not obviously the same. For example, I have students who are really good at basic algebra and understanding the slope and intercept, as long as the variables are called y and x. If they're called c and y, or if they're called, education and income or something similar, all of a sudden those concepts don't directly apply. Or they could understand slope, even take derivatives when the variables are y and x. But if they're working at profits versus output, all of a sudden it becomes a different problem, even though mathematically it's perfectly equivalent. And the only way of really getting students to do that is to give them practice problems where they do have to do some of that transferability, that transfer. And sometimes having them work in groups can help, where someone might partially understand it and explain it to others. But yeah, the ability to transfer concepts from one problem to another, which is essentially equivalent or is very similar, has similar issues, is something that students need practice with.
and it's usually the students that are right on top of their work and well researched, and they're very talented, and they just stop in their tracks. So it's frustrating. I hope I'm not alone. I don't think I'm alone.
I think we all experience that in one way or another. One way that Jim Lang does, and he talked about this when he gave a talk here, when he was a keynote speaker for one of our academic affairs retreat, is that what he often does is he teaches literature classes or writing classes, but he'd have students actually make comparisons between something they did early in the semester and then an argument or then a later reading that has some similarity. Well, he'll ask them to look at ways in which this reading was similar, and what ways is it different from the structure or the argument or the approach or the narration in this other document, by explicitly having students practice that ability to contrast and compare from one situation to another. I'm not sure how easily that could be applied in all disciplines, but helping students practice making those connections can be helpful, so that the more you can practice having students work with problems that are structurally similar, even though that may not immediately be obvious, the better they'll get at being able to do that. But it's hard, and it does take a little bit of prodding and a little bit of practice and a little bit of nudging, sometimes more than a little bit of each of those. But yeah, we don't want students to only be able to solve the problems we give them. We want them to be able to take the tools they've learned to be able to apply them to new circumstances. And there's that book, Wicked Teaching, or what is it? Creating Wicked Students, which involves facing students with wicked problems where there are no clear responses, but they can apply some of the things they've learned on that. We did a podcast with the author about a couple of months ago, I think now, maybe a month and a half ago. And he often tries to start his classes with that, where there are no obvious solutions, where you take a problem such as addressing the issue of COVID, where there is no clear answer, but you can approach the problem from different ways and try to come up with different solutions based on what you've learned in earlier classes. That could be helpful, perhaps. I'm not sure how that would apply in all disciplines, but we want to prepare students to be able to go beyond just what they've learned from their past reading and the past problems we've given them. And And that's more difficult than just, being able to recall or being able to do simple applications where they plug numbers into some formula and they get certain results back. So the best we can do is give them questions or problems or situations that lead them to have to be able to do that and give them lots of opportunities for that. At least that's how I see it. Anyone else? Okay, well, quickly, I want to go over two other approaches, interleave practice and space practice, and I'm going to lump them together a little bit, partly because in order to do interleave practice, you often are doing space practice, and most ways of implementing interleave practice involve spacing. And space practice just means that if students space their study sessions, they're going to learn more and learn things deeper than if they don't. So cramming is something that students routinely practice, but they'd be much better off if they spread their studying out over a longer period or shorter amounts of studying on every day than just doing it once a week or maybe once a month in terms of getting ready for those high stakes exams. In general, spacing has the biggest impact in terms of your ability to remember things long-term, right at the point we're on the verge of forgetting, where you just barely remember it. When you practice retrieving things when you're on the verge of forgetting them, you end up deepening your learning and remembering them much longer than if you try doing it regularly. That if you keep trying to retrieve something every day, it's not going to be as effective as if you wait a week or two before you try to retrieve earlier material. Here's an interesting study that was done by Barak. Basically, there was a series of classes that were presented or presentations that were presented. And in one case, there was a total of 6 class meetings. In one case, they were back to back. So they met for 6 days and they were tested on what they had done up to that point in each class day. In the next case, it was every other day. And in the next case, it was once a month, every 30 days, the group met. And what happened is, in the group where there was 30 days, where there was no days between sessions, students were able to remember a lot from the day before. And each day they were able to remember quite a bit. So that dominated, at least in terms of the test given on the second day, the third day, the fourth day, the fifth, and the 6th day of this. But when they were tested a month later, they forgot most things. That there was this huge drop off when students had a short class that met every day. When there was every other day, they didn't do quite as well on the second day as if it was the next day. And it got closer and they were pretty much the same by the end of those 6 class days. And they did better when they were measured a month later. So even just a day spacing between the classes had a negative immediate impact, but in the long term, it resulted in a little bit longer. It increased the ability to remember things a month later. But when classes were a month apart, what happened is that in general, not only did people do less well in each of the class days and remembering what was done in the previous, but when they were tested a month later, they did dramatically better than any of the other groups. In fact, not only did they do better than they did, not only did they do better than any of the other approaches, but they actually ended up remembering more a month later than they did at the end of the 6 months. So when they were tested on everything later, they pulled it together in a way that they did better on this overall measure of performance. So spacing between study sessions can be really helpful. And yeah, there's the actual study. And this has also been found in dozens and dozens of other studies. So spreading out study is useful. But again, if you look at that table, you notice when people were studying something every day, their immediate performance was a lot better, but they just forgot more of it. When they spread out their studying more, they didn't do as well on any of those tests, but they ended up remembering a whole lot more. But if people were asked about it, when they were getting tested all these times, they'd think about how less well, how much less they understand than they would have if they were studying it every day or if they crammed. And the problem basically is cramming works. And if we're going to be using high stakes exams, high stakes midterms, finals, and so forth, what happens is the most efficient strategies for students, if they want to get the highest GPA and get the highest performance on their transcripts, if you use high stakes assessments in class, students are going to cram and they're going to forget most of what they've learned. And it's partly the incentives that we create for them, that students do not have an incentive to focus on long-term learning if the techniques we use for assessing their performance encourage them to use things like cramming. And again, if they're most concerned about the immediate effect of the study session, as behavioral economists refer to this as hyperbolic discounting, where the immediate satisfaction is more important than the long-term gains, then we're setting up a situation where people tend not to learn as much as we'd like. And again, since most students have been in situations where routinely they've had high stakes exams, and that's certainly been emphasized by federal government policy in elementary and middle school and secondary school, it encourages people to use ineffective study strategies. And it's helpful if we could break students of that habit and encourage them to spread out their studying a bit more. And instead of doing maybe 3 hours a week of studying, maybe doing 45 minutes every day on that class would be more effective than trying to do, or just spreading it out a little bit more. One thing you can do to help encourage students to do this is have lots of low stakes exams, but throw in questions from earlier in the class. If you're going to have weekly exams, one thing you can do is you could make them progressively cumulative. I've been doing that for a few years in my intro class, where there's always going to be some questions. Most of the quiz will be on what they've just learned, but some of it will be random drawings from concepts that they worked with a week ago or a month ago or 3 months ago as we move towards the end of the semester. That automatically builds in more low stakes practice. As I mentioned, Jim Lang encourages people to use, when possible, having activities in class where students are explicitly building on concepts from before, where they make connections between what they've recently learned and what they had learned earlier in their class. And by doing that, you're essentially spacing the study, that they're taking concepts they used earlier and applying them in new contexts later in the class, but explicitly going back to that so that you're not engaged in, so you don't just focus on the topic and then drop it as you move forward. That it forces students to spread out their studying or retrieval of these concepts. Progressively cumulative exams are one way of doing it, which is what I was just talking about. Allowing repeated testing for higher grades on all content in low stakes tests also is helpful, especially if you leave them open all semester when feasible, so that students can go back and practice things from earlier in the class for a higher grade. I had to limit that a little bit when I moved to a new platform because I've been using the Waymaker package in my class. But up until then, I had written several thousand questions, and basically I let students take those quizzes over and over again throughout the semester. And I said, do you want to improve your grade? You can go. They were only at 15% of the total grade, but I said, if you want to go back and redo quizzes that you did poorly on, 2 months ago, do that. That not only will that help your learning, but it will build in, not only will that help your grade, but it will allow you to clear up any misunderstandings you have and will force you to engage in more space practice, which is helpful. Interleaved practice in practice is very close to space practice in the way it's implemented. Block practice is where you focus on a concept in class, maybe for a week, maybe for a day, and then you have students work on a lot of problems just on that particular application. You might have a present value problem where everyone works on that with different parameters until they master it. Then you move on to a new topic. In economics, you might be focusing on cost curves and you have everyone focus on that. Then you move on to, well, actually with cost curves, you'd be building on it, but you might have students focus on perfect competition in 1 week, and then you move completely from that to monopoly. But you don't make comparisons back to the competitive model, although we tend to do that by the nature of the way it's presented. But basically, or in math, you might focus on derivatives. You might focus on the chain rule for 1 week. Then you might focus on integration by parts later in the course. But you don't necessarily go back and have students work on a mix of problems. The way this is typically measured, or one classic study was done by Rohrer and Taylor back in 2007, and there have been lots of examples of this more recently. But what they did in this case is they had students, or they had people in an experiment watch 4 videos where they were looking at ways of finding the volume of cubes, of spheres, of cones, and of a 4th 3-dimensional figure that I don't remember. And what happened is, in one case, students watched a video on one and they worked through 10 problems. Then they watched another video on the other type of problem. Then they solved 10 problems with that. That was the block practice. The interleave practice is they watched all 4 10 videos, and then they had a mix of the same questions, but they were all mixed together. So not only did students have to plug numbers into a particular formula, they had to think about which particular formula was relevant, which particular formula was applied. And what happened is, with the block practice, where they worked on a problem, they worked on several examples of that, they did really well. They scored on average at about 90%. But when they had to determine not just what numbers to plug into which formula, but they had into a specific formula, but they had to determine which formula to use and which to apply, they only scored at about 60%. But when they were tested a week later, the students who had the block practice, which was easier in a sense, ended up scoring somewhere around a 20%, which I think was just about random guessing in that, because I think it was multiple choice, if I remember correctly. But students who had the interleave practice actually ended up doing slightly better when they were tested on it a week later. I think the major theme on all of this is that when something seems easy, when it's easy for students to answer questions and work through problems, they tend not to remember things as well. That if they have to struggle and wrestle with it and work harder and spend more time engaged in cognitive processing, they're going to remember it much more deeply. And so by mixing up different types of questions together as applications, it forces a higher level type of analysis. You have to now think about what type of tool do you use and not just apply the tool. It tends to increase your long-term recall. Even though this shows up a week later, other studies have shown has found similar results that show up a month and even a year later in a few studies. So mixing up questions where you have students focus on a broader range of applications all on one type of assessment is much more effective than the way in which most of our books and most of our, even this is one complaint I have about most of our adaptive learning and personalized learning systems. None of them build in interleave practice, where essentially students work with a problem, they master it, then they move on to the next topic. That is block practice. It doesn't lead to as much long-term recall as if you mix up the problems. One exception to this, by the way, is the math and chemistry problems that are built into McGraw-Hill's platform, which is ALEX. And there, students will get problems from early in the course randomly thrown in. And it bothers students quite a bit when that happens, because it seems they figured they already mastered it, they shouldn't have to go back. But that sort of practice is really helpful. And again, the way in which this is often implemented is often very similar to space practice. That, you know, if you have progressively cumulative exams, those are ways of building in this same sort of strategy. So for testing, we shouldn't use only block practice. Now, we don't really have that much evidence about whether some sort of a hybrid mix is good. We know that block practice is better in the long term. On the other hand, some degree of fluency and automaticity is also helpful. So what a lot of researchers suggest, but there really hasn't been much evidence on yet, is that we should probably do some type of combination. That when students are first learning something, focusing on that with block practice is useful, but then moving into interleave practice is likely to be helpful in terms of cementing that understanding and helping students remember things longer. So, you know, what the textbooks are doing in terms of block practice and what most of the automated systems with most publisher provided materials may be helpful, but if we can add in some interleave practice to that, as well as some space practice, it's likely to lead to more long-term recall than if we don't. We could also encourage students to mix up their study practices. Don't study things in the order in which they've learned them. They're studying for an exam. If they do use something like flashcards or questions of some sort, mix it up, just vary it, just come up with these things in a random order. If they're using flashcards, which is an effective tool actually, where the questions could be at different levels, you know, just randomly shuffle those things. Don't study them in the same order in which you work through them in class, mix them up a bit. And again, yeah, flashcard apps can be helpful and so on. And here are some resources that I put together on some of the studies out there, as well as some guidance. I'll put that in the chat. There's so much research on this. These are just a few of the more commonly cited articles on this. And again, retrievalpractice.org, and pretty much the same books that talk about retrieval practice also address space practice and interleave practice. And retrieval practice, interleave practice, and space practice are pretty much the only areas where we get incredibly robust and incredibly strong results in pretty much every study that's ever been done, whether it's from practical classroom experiments, whether it's from research on how we learn, whether it's from controlled experiments in the laboratory. These results seem to hold up much more strongly than pretty much any other method. The only other thing that sometimes is lumped in with this, and I've often lumped it in with this, but not in a 50-minute session, is metacognitive reflection, that having students reflect on their learning is also really helpful, but it's partly because that builds in some level of retrieval practice. So that's a really quick overview, and I probably should have done this for a longer period with more interaction, but was running out of time slots. And any thoughts or other ways of doing this or implementing this? Implementing any of these strategies or other related approaches? I'll stop the screen share.
I have a question about the motivation piece. So you said that this is not as enjoyable for students as other ways of studying. And it looks like there aren't the same like very short-term successes and gains for students. So I guess besides like the low stakes method, and I know like I know there was another session on Kahoot as like maybe like a fun way to practice some of this, but are there any other ideas for how to keep students from getting discouraged? Like, have you tried sharing this research with them to be like, hey, I know it's going to be tough, but this is like, I'm just curious, like how to keep up the motivation.
I do, and I've actually shared some of the studies with students, and I've shared some video recordings I've shared some of the videos from Learning Scientists where they talk about this. And, you know, I suggest that when I do this in my intro classes, I suggest to students that what we really want is students to learn things in these intro classes that they're going to be able to use when they take higher level classes. That, you know, our goal isn't necessarily to make sure they get the highest grade on every assessment. It's that they come out of the class with a level of knowledge that will let them be successful later. And that doesn't always convince people, but talking about this, talking about studies, showing them the results of that, I'm still not doing that. I'm not doing that. I've been trying to do this for years and getting students to accept this. But, you know, when I see their course evaluations, there's always things saying, well, all he's doing is making me learn this stuff on my own. You know, I'm paying for the instructor to teach me this stuff, to tell me this stuff, not for me to have to work through all these things. And, you know, and I'll tell them that's what I often see on evaluations, but here's why we're doing it, that this is going to be helpful for you in remembering things later. But again, it's hard to get students to buy into something that nothing in their prior experience in public education has really prepared them to consider as being effective. And, you know, some students will see it and some of them will say, yeah, I realize that now by working through these problems, I'm now able to answer these questions that I couldn't before. And that's one area where reflection activities can be helpful, where students reflect on how they were doing earlier in the class and how they're doing now. And, you know, having them think about what they've learned as they're moving through the course in terms of how they can address problems. Sometimes having them return to earlier problems now that they have new tools can help them see just how much they've improved in their ability to analyze problems by the tools they picked up during the course. But students pretty much universally tend to prefer passive learning. And again, there was that big study at Harvard a few years ago where students were queried about what types of classes they found most effective in increasing their learning, what types of techniques they found. And again, students strongly preferred lectures to active learning activities, but when there was a mix of the same classes, some of which was lecture and some were active learning, they always learned more in the classes where there was active learning, even though they didn't perceive the level of learning to be as high. And that's an issue. And, you know, one of the things I do in my own classes, I say, look, you know, you're going to make mistakes. That's part of learning. But in my intro class, I have it set up where they can take some quizzes an infinite number of times and only the highest score is kept, or they just have to complete them successfully using the system that we're using or the Waymaker system. They just have to actually complete the whole thing and attain some level of mastery in it. And then they get full credit for that activity. And I say, you know, here, there's no penalty for making mistakes. You should do that before class. And then when you come to class, there are these clicker questions where many of the questions you'll be asked twice, first individually and then after you discuss them. And even if you get some wrong, you're still getting partial credit for doing that. But then at the next stage, you're going to take a weekly module quiz, and there you're going to have 2 chances at it. So, you know, the stakes get progressively higher. So if you practice this material over and over again until you attain mastery of it, you're going to be able to do better on these other things where you don't have as many opportunities. And then eventually there's going to be a midterm and a final exam, although I did do away with those for the last 2 years because of the pandemic, where they've only had the weekly quizzes that were progressively cumulative though. You know, you're going to be able to do better now that you've attained this mastery. Even though you struggled, you're struggling at a time when it didn't cost anything to make mistakes. And that's the time to make mistakes rather than when you get to a high stakes exam. Some people buy it, some people still would rather just be lectured to and only have a small number of exams that they can cram for. And, you know, it's hard to get past that. So it's easier when you have tenure and you don't have to worry so much about course evaluations, but if you can sell students on this, it can be really helpful. And it's in their interest to be able to do this because it will help them for the rest of their career in college and beyond if they learn these techniques and learn that, you know, making mistakes is not a sign of failure, but it's a part of the process of becoming successful and attaining a higher level of understanding. You know, and sometimes in my classes, I'll talk about how economists first viewed a problem this way, but then they did some other research and found that didn't quite work, but they tried something or they came up with a model and it worked up to some point, but then it didn't explain these other things. And it forced people to reconsider that and come up with a more improved model that allowed a higher level of understanding. And, you know, that type of thing can help a bit too. So. I don't know. Anyone else have suggestions on that?
I just want to say quickly, I was surprised, and you might be able to, by what you said about that data about students prefer lectures versus active learning. I know that in the School of Business, now granted that's a small sample size, they all prefer active learning and then to being lectured to. And I don't know what the other people on this session have found. I mean, I'm not doubting the data, but I'm an old fashioned. I think lecture is the best lecture, and then some opportunity to do some active learning. But most of my students would not buy that.
Well, actually, there is some studies that suggest that a mix of lecture or interactive lectures can be more effective than an entirely flipped classroom in intro level classes. And partly it's because it imposes some structure if that's not imposed in other ways in the design of the course. And actually, there's a book called Dynamic Lecturing, which talks about that interactive lectures can be more effective than pure lecture or than a completely flipped environment, which is entirely interactive. It depends on the discipline and the context, but every study I've seen has found that students tend to prefer cramming. They tend to prefer lecture to active learning activities. And there have been some pretty large samples on that. We haven't done any here. We haven't done it disaggregated that by schools as far as I know, but especially freshmen, I think, or what the study seemed to suggest is that freshmen in particular tend to prefer lecture. Now, they might be bored by lectures, but they find it more intuitive and they feel that they're getting their money's worth out of the class. And they often will feel that they understand it better after a lecture than when they're faced with problems that are somewhat more challenging, which don't have obvious answers. So I don't know, maybe students are different, or maybe it's something about the nature of the discipline or the courses that make active learning seem more interesting. And you have to do something that works for you too. You know, it has to be something that works for your students, but something that works with your own, what makes you comfortable. Because if you're not comfortable using a particular technique, then, you know, it's not going to come across as well as if it's something that you buy into. Other thoughts? And again, I wish I had a good suggestion on the motivation thing. Mihai, any suggestions?
Not necessarily, but referring to the part about communicating good practices about learning to students, I do something like that. Basically, it starts before every lecture day. I have a nice little poster that embeds, you know, it's pretty much an image summary of Make It Stick, the book that you mentioned earlier, that you know, points to don't cram. There's another thing that's showing a recycling sign, learn, forget, and relearn, pointing to this idea of retrieval practice. And you know, more often than not, before I start the class, I usually point them to various techniques. I pick one every week, and I, you know, cycle through a series throughout the semester. I'm not sure how much benefit it generates, but you know, even if I manage to convince a fraction of the students that these are worth taking a chance on, I think it's mission accomplished, given that, you know, the course is, you know, it's an economics course. It's not a course about learning how to learn. What I also do, there's this practice, learning practices inventory, where they actually go through a little survey, and then basically they would check various techniques that they would apply in the course. And then based on that, they can calculate a particular score, and that score is attached to a predicted grade in that course. So what I'm doing this semester is, in fact, I'm going to offer credit for them completing it and submitting it. So I'm going to be grading it only for completion basis. But what I want them to get from it is that, look, there are these techniques that if you actually use, your predicted grade in the scores is going to be higher than the one that you get by doing what you already do. So I think that there's, we can actually make small interventions in sharing with students, these practices that actually generate results. I don't think we should expect too much off of this, but I think we should try in sharing with them these techniques. There's also another thing that I share with them that's called Learning Strategies. Is from a book by Sandra McGuire.
I was going to say, I think wasn't the other approach too, where you plug in the strategies that generate it? Wasn't that something she referred to?
I think I got that from AQ.
Okay.
When we were doing the effective teaching practices course, but Sandra McGuire refers to that too. So then there's this chapter, if I'm not mistaken, chapter 5 in that book, Learning How to Learn, which in essence presents 10 strategies for, in essence, retaining more and in essence, learning more. I mean, there's a lot of overlap between that chapter and what you presented here, John. But I share that with them. I photocopied the chapter from the book, and it's shared on Blackboard and is referred to, on slides before we start the class. Hopefully that makes a difference, at the margin. Certainly students have a lot on their plate too. So, and certainly this involves changing behaviors, which we all know. It's hard to change. So I guess aiming for incremental steps here might be something that would generate more results. I'm not sure if any of these are shared in the those freshman courses. There's some courses that
They should be, but they generally are not. It's something, yeah. It would be nice if they were.
Even if they're sprinkled there, here, by the way, these may help you.
Yeah,
it might help.
Yeah, I was for a short while on a committee related to that, but I kept arguing against the use of learning styles and other things, so I ended up getting disinvited from that because I kept citing research and it disagreed with some of the priors of some of the people running that. So. Yeah, I mean, some of that they do, and a lot of it is time. They tend to focus mostly on time management, which is a big issue, for students, for all of us, I suppose. But it would be nice if that was built in a bit more.
Because if they focus on time management, then it makes sense to focus on strategies that actually deliver results, right? And then they would save you precious time come an exam time if you've, relearned. Practice, implemented these practices. You don't have to waste as much time studying for an exam. You go in prepared for most of the stuff. So
yes, that would be an approach that an economist would argue, but they tend to focus on making schedules and so forth, and coming up with a time schedule. And the strategies they use are good, but I always would like to, we're going a bit over time, and I've got to get to a meeting too in just another minute. But it would be good if there was more focus on teaching students effective learning strategies.
yeah.
Okay. Well, thank you.